Intelligent Transportation Systems Podcast. Bart van Aren, Matthew Barth, John Beck, Alberto Brocci, Frank Truss, Andreas Hegyi, Matthew Karlaftis, Eberhard Kraus, Jeffrey Miller, Katsuhiro Nishinari, Cristina Loberri Monreal, Vincenzo Punzo, Emily Sopensky, Miguel Ángel Sotelo, Christoph Stiller, Tsuneo Takahashi, Julius Ziegler. Hello, do you know what is that list? These are some of the voices you have heard during the last year at the ITSPodcast. 12 amazing episodes on the knowledge frontier of intelligent transportation. Yes, this is our first anniversary. Happy anniversary to all of the ITSPodcast community. Let's celebrate. I'm Javier Sanchez Medina from the IEEE Intelligent Transportation Systems Society. This is a special episode of the ITSPodcast for May 2014. We have some special contents today. We have a short interview with the current ITS Society President, Professor Matthew Barth. We will unveil the ITSPodcast Best Follower Contest winner name in the middle cut of a very interesting interview to Professor Hesham Rakha from the Virginia Tech Transportation Institute. We also have some good news at the news Minisection. We have prepared all of this for the very special listeners we have, like you are. We really hope you enjoy it. Let's start. Okay, now we are with Professor Matthew Barth from University of California, Riverside. He has recently started his term as president of the IEEE Intelligent Transportation Systems Society. Hello, Matthew. How do you see the current situation of the IEEE ITS Society, home society of this podcast?
Well, hello, Javi. It's great to be here today. So, yeah, the situation with the IEEE ITS Society is it's very good. We're doing very well. We have a lot of new interesting things going on, and so I'm very proud to serve as the president for this year and next.
Oh, that's great. What are your main priorities as president during your term?
Well, there's a number of things that we want to do in the next couple of years. So we're still a very young society within the IEEE. We have obviously a lot of members, but we do want to increase our membership. So there's a lot of different avenues and different people we can reach out to join the ITS Society. ITS in general is a very fast-growing field with automated vehicles and other interesting topics. So I think growing the membership for the next couple of years is one of the main priorities. There's other things we want to do too. So again, because we're relatively new as a society, we don't have very many chapters, right? So student chapters and chapters by region. So that's another goal, is that, we do have enough sort of critical mass of membership that we can start forming these chapters. And these chapters can form and people can get together locally and talk about recent issues and topics related to intelligent transportation. So we're making a big push for increasing those chapters. And then lastly, as the society grows and interacts with other things, what we want to do is really put ourselves out there and join some new initiatives. And so there are some new initiatives already underway. There's this reasonably large effort looking at transportation and electrification. And so that's something where the ITS Society wants to play a role. And there's going to be other initiatives that come up too, dealing with connected vehicles and wireless communication and all that. So again, I think this is core to what we do within the ITS Society, and we want to continue to promote that through these support of the new initiatives. So quite a number of things we want to do.
Mm-hmm. I've heard that you are preparing a new transaction. Is that true?
Yes. In fact, we've had our transactions on intelligent transportation systems for several years now. I mean, over 10 years, and it's very popular, right? It's one of the leading transportation journals transactions out there. And so we're at the point now where our number of papers within those transactions have expanded, and we want to create a new transactions. And this transactions will be called the Transactions on Intelligent Vehicles, and it will focus obviously more on the vehicle side of ITS. And so we just started that process, and we're hoping to grow that transactions and get it launched here very shortly.
Oh, excellent news. Finally, Matthew, what do you think about this new publication, the ITSPodcast?
Well, I think this ITSPodcast is one of the cutting-edge things that we're doing within the IEEE Society. So, the idea is to reach out with different media. It's always been print media and things like that. But certainly we should take advantage of modern technology, and the podcast is right there. So I think it's a great concept. It's been very popular so far, and I hope its interest increases in the coming years.
Great. Thanks for your words. Okay, thank you very much for these brief comments, and the best luck for the next 2 years. Goodbye.
Thanks very much, Javi. Bye.
This is the news mini-section for episode 13, May 2014. We are proudly announcing the publication of a very interesting article in the last April's IEEE Institute periodical on 3 honorable members of the ITS Society. It is entitled The Drivers Behind Autonomous Vehicles, and it talks, as its subtitles, about the contributions of 3 IEEE fellows who have pioneered the technology for self-driving cars. They are the IEEE Life Fellow Professor Robert Fenton, the IEEE Life Fellow Professor Umit Osgunner, and the newly elevated IEEE Fellow Professor Alberto Broggi. They are distinguished, brilliant researchers from 3 different generations on the field of autonomous driving. We really recommend it. We are including the article's link in this special episode post in our website at itsp.cicei.com.
If you read the IEEE Intelligent Transportation Systems magazine, you have probably read a very interesting interview column on an amazing colleague, Professor Hesham Rakha, who is director of the Center for Sustainable Mobility at the Virginia Tech Transportation Institute. They are doing a lot of very interesting research in that center. We have tried to cover many of the topics they are dealing with, since it is quite representative of the hottest topics right now in intelligent transportation everywhere. We hope you enjoy it. If you usually go to the Intelligent Transportation Systems Society's conferences, you'll surely have met my guest today. He's a regular. And that's very good for us, because he always puts in good and innovative research. Today I have the great pleasure of speaking with Professor Hesham Rakha. Dr. Rakha is a professor at the Charles E. Villa Jr. Department of Civil and Environmental Engineering and director of the Center of Sustainable Mobility at the Virginia Tech Transportation Institute, VTTI. Hello, Dr. Rakha. Would you please introduce yourself to our listeners?
Okay, I guess given the introduction you gave me, there's not much to add except that I would mention that I did my undergraduate in Cairo University in Egypt, and then I did my master's and PhD at Queen's University in Canada, and then moved to the US in 1997 to work here at Virginia Tech. I've been a faculty in the Civil and Environmental Engineering Department since 1999, and I guess I've continued to work in this area since moving here to Virginia Tech.
Great. Hesham, you have recently been the subject of a column in the Intelligent Transportation Systems magazine at its winter 2013 issue. And I see you have helped a lot attracting a lot of money to your university. Actually, it says over $30 million. That is a lot of money. And it shows that your center is very well considered for administrations and also private funders. How do you do that?
I guess there's luck. Always there's you're being fortunate. There's hard work. I think that the key is knowing what the sponsors need, identifying key research issues that need to be addressed, and trying to be at the forefront when the need arises. And I should mention that this $30 million is not just me. It's I'm involved with other researchers here at the Virginia Tech Transportation Institute, and it's a team effort, I guess, across various personnel.
Mm-hmm. Your center is currently working in the US Connected Vehicle project, right? Would you be so kind as to explain to our audience what is connected vehicle? What is that concept about?
Okay, so the concept of connected vehicles is basically having vehicles share information, and they can share that information either with roadside units, or what we call RSUs, or roadside equipment, RSEs, where they can transmit certain information to these units. Those units can then transmit it to the cloud, and then you can do some computation and send it back to the vehicles. Alternatively, the vehicles can share their information with other vehicles, so vehicles can connect with one another. So basically, you have two types of connectivity. One which we call V2V, which is vehicle-to-vehicle connectivity, and one V2I, which is vehicle-to-infrastructure. And then sometimes they call it V2X, where X could be any type of system where you can connect to. And the essence is if you can share that information, you can improve the mobility of the transportation system, the safety of the transportation system, and reduce the carbon footprint of the transportation system through the exchange of information, where vehicles might be aware of have more information than they would have if there was no exchange of information.
Sounds interesting. How is the Virginia Tech Transportation Institute contributing to that important project?
So the Virginia Tech Transportation Institute actually won what we call a University Transportation Center, and the theme of that center is vehicle connectivity. So we, and actually the director of the VTTI, Dr. Tom Dingus, he's the one that was leading it. I'm a co-PI on that project. And basically, the research is focusing on coming up with ways to improve the safety, the mobility, and reduce the carbon footprint through vehicle connectivity. We're building a number of test beds as part of that project. One of them is a fairly large test bed in Northern Virginia, which is in the Washington, D.C. area. And the Virginia Department of Transportation is actually building that test bed as part of the match that we need for this project. Me personally, I have a number of projects working on the test bed and in other areas here in Blacksburg related to vehicle connectivity. If you'd like, I can elaborate on them, but now I'll just close it here, and then if you have more questions, I can get into the specifics of those projects.
I've seen something curious. I've seen some folks also talking about connected bicycles into this project. Do you do that in Virginia?
Yes. So actually, one of my students, he's looking at vehicle connectivity between bicycles and vehicles in order to reduce the number of crashes that involve bicycles. So basically, you can have a warning system that would warn a vehicle and the driver in the vehicle when they get too close to a bicycle. And also it could warn a vehicle if a bicycle were to be running a red light or running a stop sign. So basically, we're trying to reduce the fatalities associated with bicycles through a connectivity between those bicycles and the vehicles.
Hesham, we have recently heard of California leading the way again, trying to take bigger steps towards building a sufficient hydrogen stations network. This would support car makers in accelerating their plans of selling that kind of zero carbon emitting cars. As director of the Center for Sustainable Mobility, how is your center trying to put Virginia in that race?
So I guess we're doing in a number of areas. One of them where we've developed models that estimate the vehicle fuel consumption and energy consumption for regular vehicles, for hybrid vehicles, and we're also looking at electric vehicles and coming up with ways to identify where the locations of the charging stations should be in order to for drivers to be able to use such systems. So that's in a nutshell what we're doing here within our center.
In a previous episode, we interviewed, talking again about California, we interviewed the director of the Center for Environmental Research and Technology, maybe you know him, Matthew Barth, at California Riverside University. And we asked him similar questions to this I'm placing now to you. Do you perceive, I think this is important for a director of a center as you are, do you perceive an actual interest on the network users side on driving more eco-friendly? Do you think, for example, that traffic authorities should reward drivers of more eco-friendly cars? I don't know, perhaps some tax reductions or other incentives?
Personally, I think the rewards for driving eco-friendly will actually come directly by the reduction in the fuel consumption or the energy consumption of the vehicle. So I think the rewards are direct to the driver. I think the key is displaying that information to the driver so that they get the feedback and they see the benefits of the EcoDriving. So we've worked on ways to do that. So, for example, you might have a display system that just shows you the savings that you're incurring as a result of your EcoDriving. Or if you're getting into automated vehicles, the vehicles can actually drive in a way that is actually eco-friendly without the driver actually noticing. So you can have the vehicle doing the work behind it, or you could have the driver trying to follow some guidelines that you are giving to the driver. So there are different ways. In addition, there are eco-driving ways that we're looking at, for example, to the vehicle connectivity, where you can receive traffic signal information. So, for example, if you're arriving at a traffic light that is currently red, that will be turning green, say, 10 seconds into the future, and there are two vehicles stopped at the stop line, we can, using that information that we receive from the traffic signal controller, come up with a fuel-efficient way in order for you to arrive, for example, 10 plus 4 seconds, which is the additional 4 seconds to discharge the queue at the traffic light in a way that is fuel-efficient to reduce its fuel consumption. And that can either be displayed to the driver by a speed profile, or it could be directly controlling the adaptive cruise control system of the vehicle without the driver noticing, and then using that information to come up with better fuel-efficient ways to reduce fuel consumption.
That's very interesting. Very well. Now I'll need to make a very short break. Please stay tuned.
Okay, thank you.
Hello again. It's now time to announce the winner of the ITS Podcast Best Follower Contest. To all of those who tried but did not win it, we have to say a big thank you, and also to beg them to keep on helping us out, disseminating this show the best they can. Let's go now with the winner. His name is Mehran Shirazi. We have just recorded a shortcut interviewing him. I'm very happy to create and introduce now the winner of the Best ITS Podcast Follower Contest, Ms. Mehran Shirazi from Vancouver, Canada. Hello, Mehran. Congratulations.
Hello, Javier. Thank you very much. I'm really glad that I'm selected as the winner of the Best Follower Contest.
Right. What do you do for a living? Do you have any professional interest in our show, or is it just for fun?
Well, actually, I have a background in electrical engineering with a specialization in control systems. Currently, I'm a PhD candidate in Simon Fraser University in Canada in the Department of Mechatronic Systems Engineering. My current research is focused on designing advanced driver assistance systems, also on driver modeling and detecting impaired driving and drunk driving.
Sounds interesting. Well, I have to say thank you very much for your help. You have done a very impressive work retweeting our tweets right in the minute they were produced, sharing our contents, and attracting your friends and colleagues. Thanks for that.
Well, actually, I have to thank you for making and producing these great podcasts. They are very informative, my friends, and I really enjoyed them.
What do you like the most in our shows? What is your favorite content? Any specific interview or something?
Well, the thing I like the most about the podcast is that the contents are presented in a very simple way such that it is attractive to even general audience, and everyone can understand it without having much technical knowledge about the topic. I also really like that you interviewed famous researchers and scientists that I have read their publications. And the questions asked from them were, at many occasions, exactly the questions I liked to ask them previously. So I really liked the choice of questions you had. Regarding my favorite interviews, since my research area is related to human factors, you had a couple of podcasts which were related to human factors. They were the most interesting ones for me. Also, those small sections on history of transportations are very useful and interesting. Please continue to have them in your podcasts.
Oh, that's awesome. Thank you for your kind words. Okay, thank you again, and please keep on collaborating with us the way you do usually, because we really need our followers' help to get a wider community of listeners month after month. So thank you, Mehran.
Sure, definitely.
Thank you. Goodbye. See you soon.
Goodbye. See you. Bye.
We're back with Professor Hesham Rakha. Hesham, another exciting and hot topic you're working on is the use of probe vehicles to get a more accurate and real-time image of the current situation, of the current traffic situation, Can you please explain what is probe vehicles? What kind of project you have under development with this regard? For example, what kind of vehicles do you use as probes? Taxis, private cars, trucks?
Okay, so basically a probe vehicle is a vehicle that is driving in the traffic stream naturally, and you'd like that vehicle to be driving the same way that the average vehicle will be driving in the traffic stream. The only difference between this vehicle and a regular vehicle is that this vehicle is reporting back information about its experiences while it's traveling. So, for example, you could have a GPS unit on the vehicle that is tracking its position and its speed over time. You could also be reading off its fuel consumption and so forth. So that information gets fed back to a traffic control center, and then you can use that information to come up with better strategies to manage your transportation system. So some examples that we're using probe vehicles is one project that we're working with the Virginia Department of Transportation. The objective is to predict the travel times from Richmond, which is the capital of the state of Virginia, to Virginia Beach, which is a city on the beach. And typically on the weekends in the summer, people travel to Virginia Beach in order to get to the beach over the weekend. And they want to display to the drivers the travel times on these variable message signs that will tell you, for example, it will take you 2 hours to get to your destination. So we're looking at ways to use probe data from vehicles that are ahead of you to predict what the travel time is going to be, given that the distance is about a 2-hour drive. Plus, we want to predict 1 hour into the future so that you can decide maybe right now it's congested, maybe I should leave 30 minutes into the future in order to avoid the congestion. And so we have to predict what's going to happen in the future over the next maybe 3 to 4 hours.
Wow.
So we're using, we actually won, our paper actually won the Best Paper Award in the 2013 ITS World Congress. This was on travel time prediction using pattern recognition. So we're using pattern recognition to identify from a historical database of spatiotemporal speed measurements what are similar days and similar times in those days to the current day, and using that to predict what the future will hold over the next 2 to 4 hours.
Well, congratulations on that word.
Thank you.
Could you please tell us what is the title of that paper?
Okay, so the paper is entitled Dynamic Travel Time Prediction Using Pattern Recognition, and it was co-authored by my student, who was the first author, Hao Chen, myself, and Catherine McGee, who works with the Virginia Department of Transportation.
And you won the Best Scientific Paper Award for North America at the 2012 ITS World Conference, is that right?
Yes, so in addition to that one, we also won in 2012 a paper which was optimizing driverless vehicles at intersections.
Wow, congratulations on that.
Thank you very much.
In that second one you have mentioned, you talk about managing driverless vehicles at intersections using a multi-agent system. Is that right?
That's correct. So basically the concept is using vehicle connectivity where vehicles can communicate their locations and their speeds to a roadside unit at the intersection. The intersection controller then receives all the requests. So when vehicles are within a certain distance, which is around 200 meters, if you're using DSRC connectivity, we receive all the requests similar to what you have on a runway at an airport. So when planes are arriving at the runway, they send in the requests, and the air controller will actually tell this plane you land, this plane you wait, and so forth. So we do exactly the same thing. We're trying to minimize the total delay of all the vehicle requests, but at the same time prevent any crashes between those vehicles. We receive those requests and we tell this vehicle, you slow down to this speed, this vehicle you can proceed, and so forth, in order to achieve that objective. We also just recently added to that based on we have a lower level optimization that once we identify when each vehicle should be proceeding to the intersection, we identify the most fuel efficient way to reach that point in the intersection at that future time in the intersection. So we have a multi-objective. We're preventing crashes, we're minimizing delay, and then after that, we're minimizing fuel consumption of vehicles.
Mm-hmm. I'm assuming that for this case, you will have driverless vehicles, right?
Yes. So in this case, it's assuming that we have driverless vehicles. We also took into account that, say, only maybe 10% of the vehicles are driverless and the other 90% are non-driverless. So we looked into the possible interactions of both driverless and drivered vehicles and looked at what are the potential benefits of having different levels of market penetration of these systems in our system.
Uh-huh. In general, do you think that they will rule that every vehicle will finally be automated, no matter how much many of us like driving? You know, there is that controversy, even in the scientific community, on if this is happening or not. Where do you put yourself?
So I personally love driving. But I think there are times where even as a person like myself who loves driving, if you're stuck in congestion for over an hour, you will not be enjoying that. So I think the driverless vehicles can be very helpful in the conditions where you're stuck in congestion on a typical commute, for example, in Northern Virginia, here in the US, in Washington, D.C. And so basically you can be doing your work while you're trying to get to your destination. Another example would be if you're traveling on a long trip, and that in the US here, I mean, I typically travel 11 hours when I go to my in-laws up in Canada, and that's in one shot. I do that driving. So if I could have a driverless vehicle that could help me in that would be a lot of assistance. So I see things going in that direction. I see, like, for example, the Googles and so forth going that direction. I think it's going to take some time, both from a policy standpoint and getting all the systems working together. It's going to be much more challenging than what people perceive right now in terms of implementing these systems.
Mm-hmm. I'm just imagining, thinking about that automated intersections, you know, wouldn't it be terrifying to be in that cars and approaching that intersections? I don't know. I guess sometimes it will accelerate to cross it. I've seen videos of other cases with all the cars merging and crossing that intersection. Do you think we will get accustomed to that?
Actually, I'm originally from Egypt, and we have similar intersections without any automation. And drivers get used to it. So I think, of course, there will be a learning curve. I think you also have to have a buffer of safety when you're designing these systems. So, for example, if you do lose connectivity, how are you going to deal with that system? Mm-hmm. And that's one of the reasons why we actually looked at, for example, looking at these systems on roundabouts. So basically, a roundabout will provide you a safety net that if you were to lose connectivity or if the system were to break down, that the driver would know what to do, that the driver approaching the roundabout would yield to the vehicles on the roundabout. All we're trying to do is slow down the vehicle. So typically we're not accelerating them. We're actually slowing them down so that when they arrive at the roundabout, they arrive at a time when there is a gap between two vehicles so they can merge on very easily. So I think initially you're going to have to go with some systems where you have a safety net, like a roundabout, that if your system were to break down, you have a safety net to protect those drivers from having collisions.
Mm-hmm. That's interesting. Okay, Hesham, this is it. Thank you very much for your participation in this show and your tremendous contribution to our research topics and our society as well. It's encouraging for many of us.
Thank you very much for interviewing me. It's a pleasure and honor to be on this podcast.
Goodbye.
Goodbye.
Well, we are now reaching the end of this episode. It's been a great year, but we will always try to do better episode after episode. With your help, our loved followers. Thank you. Please keep on pushing. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicon, language advisory by Manuel Arbelo and Professor Son Williams from Clemson University, South Carolina. The initial Happy Birthday adaptation was performed by the Chamber Orchestra Kremlin, conducted by Misha Rachlewski. We'll be back soon, bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.